friends, welcome to the video lectures on technical C by Shravan Kumar Manthri. Coming to the question number 3. This is about finding Armstrong numbers. So first of all, we have to know what is an Armstrong number. So it is a number that is a sum of its own digits. And here not only sum, each is raised to the power of the number of digits. So let me clarify this one. Let us suppose if I take this example 153. So now I call 153 as an Armstrong number. Why? Because you can see here in 153, if I take, first of all I have to take the numbers, that is 1, 5 and 3. So you need to make sum of their power raised to the number of digits. How many digits are there totally? 3 digits. So I need to make 1 cube, 5 cube, 3 cube. Now if I make the sum, you can see this one cube, that is 1, this is 125, this is 27, totally 153. Now I need to get the same number. So like this, if there are numbers exist, that we call it as Armstrong numbers. Now you can say these are all Armstrong numbers. Let us suppose if I take only one digit, 1 power 1 equals to 1, 2 power 1 equals to 2, that is 3 power 1. You can see this one 370, 3 cube plus 7 cube plus 0 cube. Why I made it as cube means 3 digits. So here also 3 digits, here also 3 digits, and if you go for 4 cube plus 0 cube plus 7 cube, you will get 407. You can check it. And what about this one 1634? That means 4 digits are there. Now I need to take 1634 and each to the power of 4. Why? Because totally we have 4 digits you need to consider. So now if I make sum, I'll get 1634. And even if you go for this one, 8 power 4 plus 2 power 4 plus 0 power 4 plus 8 power 4. Like this you have Armstrong numbers. So these 3 are Armstrong numbers of 4 digits. These 4 are Armstrong numbers of 3 digits. And these are 1 digit Armstrong numbers. Of course you can say that there are no 2 digit Armstrong numbers. So now how to write a program to get all those things? Let us suppose if I give 10,000 is the range, I have to get all these numbers. Let us suppose if I give 100, now I need to get only this first row. If I give only 500, so I need to get till 407. So how to get that one? We'll see that programming now. Here I have taken a number of variables. We'll see how they are useful. Enter a range. So what is the range that you want to enter? Whether it is 100, whether it is 1000, whatever it may be. Now I'm taking that value in R. Let us suppose if R value is, of course in our example I have taken 10,000 like this. Now I have taken n. What is n? N equals to 1 up to n less than or equals to R. That means what we are doing here is, I have given the range as 10,000. That means till 10,000. All the numbers I need to check whether each number is Armstrong or not. So in order to check that one, n I have to start with 1. Now till that number, let us suppose if I give R value as 100, so n value will become 1, 2 like this up to 100. So that is a loop here I have written, and this is S equals 0 in order to find the sum of this, and C equals 0, count of the number of digits, and K equals to n, that is a temporary variable, P equals to n, also one temporary variable, that is a copy of the original value. I am placing it into K variable as well as P variable. Let us suppose n equals to something 1, means K also will become 1, P also will become 1. That means 2 copies I am taking for the value which we are checking for Armstrong number. Let us suppose n value is something like 250. So K value will become 250, P value will become 250. So why it is required, you can see here. Now you can see this is a logic, this loop is a logic to find number of digits, in a given number. Let us suppose here if I take the example of something like 153, your C value will become 3. So why? Because 3 digits are there totally. Let us suppose if I take 8208, now C value will become 4 because total number of digits are 4. So in order to get that count, you can see while K is greater than 0, initially C value is 0, C 1, C plus plus, that means C value will become 1. Next K by 10, So what happens, I'll explain with one example how we can get the count. Let us take this 407, let us suppose. So k value 407. 407 is greater than 0, that's why c value will be incremented as 1 because it is 0 initially. Next, k equals to k by 10. Now k value will become 407 by 10. 407 by 10, it will become 40. Only quotient we need to consider, as this is an integer. Now it will goes to the loop. K value is 40. 40 is greater than 0. Yes. Now c value will be incremented to 2. Now 40 by 10, which is equals to 4. Now 4 is greater than 0. Now c will be incremented to 3. 4 by 10, which is equals to 0. Now 0 is greater than 0. No, comes out. Now you can see the count 3. Similarly, if you take this one, you will get the count as 4 for this number 8208. Like this, you will get the count here. After getting the count, what I am doing here is, while p is greater than 0, what is p is greater than 0? Let us suppose if I take the number 153. 153, you will get here also another copy. So let us suppose if I don't take this p, if I want to take k value here, it became 0 after execution of this. That's why I have not taken again k value. That's why I have taken one more variable, that is p. So p is greater than 0. Yes. So p percentile 10. What is p percentile 10? Let us suppose if I take 407. 407 percentile 10, which is the remainder I require. 407 percentile 10 means what is the remainder? 7 is the remainder. So here sum equals to s plus s equals to s means 0 plus power function. So what is the meaning of this one? Means it is indirectly d power c. Like power of what is d value? 7 comma what is c value we received? 3. So power of d comma c will give 7 power 3. That is 7 comma 3 means 7 power 3. So s plus 7 power 3 you will get here. Then p equals to p by 10. That means p value will become anyway 407 by 10. Now it will become 40. Now 40 is greater than 0. Yes, 40 percentile 10. You will get 0. So 0 comma 3. That is 0 power 3. So you will get 0 power 3. Anyway it is 0. Next you will get 40 by 10, which is equals to 4. Now 4 is greater than 0. Yes, 4 percentile 10, which is 4 only. Now here you can say 4 comma 3. That means 4 power 3. Now you can say 4 power 3, 0 power 3, 7 power 3. That means, can I say it is a sum of the cubes? Yes. So like this, then again 4 by 10, which is 0 you will get, and it comes out. Now what you need to check it out, what you have here. In k you have 0, in p also you have 0, but our original value in n. So I need to check n with whatever the sum you received. So both should be equal, like 4 cube plus 0 cube plus 7 cube should be equals to 407. If that is the case, I am printing that number. Otherwise I am not printing that number, or else you can write here n also, both are equal anyway. So like this it will check for each number. If both are equal, then only it will print. Why? Because it is an Armstrong number. When it is Armstrong number, it will satisfy these constraints, then only it will print the numbers. Otherwise it will go for the next number and it will check. If this satisfies, it will print the number and it goes for the next number to check for Armstrong. If it is not, it will not print anything and goes for the checking of Armstrong number. So like this it will repeat until your range that is given. So like this we need to proceed for finding Armstrong numbers within the given range. So we'll see in some more questions in the next video lecture. Thank you.